Here's a model of a linear equation, and this model represents the surface area of elevation of Lake Powell T years after 1999. This shows how linear functions can be used in real-life situations. What they want us to do in problem 1 is complete the table for this function. So we're going to plug 0 into this function, and we get 3,861 minus 77.2 times 0, or 3861. Next, we're going to plug 1 in. 3,861 minus 77.2 times 1 is 3,783.8. In year 2, 3,861 minus 77.2 times 2 gives us 3,706.6. In year 3, we're plugging 3 in for t, and we get 3,629.4. In year 4, we're plugging 4 in for t, and we get 3,552.2. And 5 years, we get 3,475. So we just plugged in our t into this equation in order to fill out the table. Identify the vertical intercept for this linear function. Write it as an ordered pair, label it, and interpret its meaning in a complete sentence. So the vertical intercept, if t is equal to 0, what's left over? 3861. So our input is 0, our output is 3861. That means in 1999, because that is year 0, the lake started at 3861 feet above sea level. Determine E of 2. Well, luckily we did that up here. What does that mean in a sentence? So E of 2 is 3706.6. Year 2 was 2001. In 2001, the lake was at 3706.6 feet above sea level. Identify the slope and write its meaning. The slope is the number that is attached to our input, so the slope is negative 77.2. What's happening every year? The lake is decreasing by that amount each year. So the lake is decreasing by 77.2 feet per year. Notice I didn't say it was decreasing by negative 77.2. The negative is telling me that it's decreasing. So all I need is the number, not the sign. Determine the practical domain and practical range of this linear function. Use set builder notation and include units. So let's start with the domain. What sort of inputs do we have? Well, the inputs that we have are, this is set builder notation. We start with a curly bracket. We put our independent variable in there, t for time, in a vertical line. That vertical line means such that. T such that t is equal to 0, 1, 2, 3, 4, 5. We could also write this if we wanted to include any decimals inside. The lowest value for t is 0, which is less than or equal to t, which is less than or equal to 5. And that's because we only have those 6 years worth of data. The range is going to be our outputs, e, such that the lowest value that we have is 3,475, because that's all the data we have. That's the lowest number, less than or equal to e, less than or equal to the highest value, which is 3861. We could have also written out our range as individual numbers like we did with D, but this is a more accurate way of writing the range in set builder notation.